You're starting chapter 2 to have some definition on atom and elements. On chapter 1, we talked about the measurements, the units of the measurements, the numerical value of the measurements, and how to work with those. So in chapter 2, we're going to start from some discussion. We are going to have some, we're not going to talk about numbers. We're going to talk more about chemistry and definition. And then later on, we're going to move back to doing numbers, solving problems. Okay, so atoms and elements. So let's start with these slides and let's see how the modern atomic theories started and the laws that led these theories to happen. So the law we already talked about law of conservation of the mass. We know that in a chemical reaction, which is basically a chemical change, matter neither created nor destroyed. So if you look at this picture in this figure that is shown in these slides, if you add sodium with the chlorine gas, if you have this exact masses, considering that it's completely reacted, you see that the total mass in the reactant is 19.6. You will get NaCl, which is, as you know, the table salt. You will get 19.6 of the salt. That was something that was always true, and that was the law of conservation of the mass. You do not create or destroy mass in a chemical reaction. Then scientists started to make some hypotheses and come up with some theories that why is this happening. So it was John Dalton who came up with the atomic theory. So it's called Dalton theory or just atomic theory. So he came up with a theory to explain the conservation of mass or some other observed laws. And his work was actually the beginning of the modern chemistry that we have, the modern definition of the atom. Before that, there was no definition for the atom, so they were just doing the chemical reaction, they were just mixing things, and what they always observed was that the mass of starting material was always the same as the mass of product. There was no difference in the mass. So his theory was basically 4 statements. So these are the 4 statements of atomic theory. So the first one is elements are composed of tiny indestructible particles called atom. So this is the first time that they used the word atom in chemistry. So you have to know that these 4 statements, not all of them are still true. So the first one says that if you have an element, anything from the periodic table, and if you just separate everything to the smallest part, there is an indestructible particle which is called atom. Okay. The second one is all atoms of a given element are identical, and the atoms of one element are different from other elements. So if you take, for example, aluminum and you separate all the elements until you go to the smallest one, which is atom, all of these small particles, which are called atoms, are identical. Okay, and if you do the same thing with a different element, which is, for example, iron, and you just separate everything to the smallest particle, smallest, as Dalton said, air quote, indestructible particles, which are atom, you can see the iron atoms, and they are also identical to each other, and these two are different. I mean, the aluminum atom is different from iron atom. So that was his second statement. The third statement says that compounds are composed of atoms of more than one element. If you recall, our first or second video that we were talking about matter and how we can classify the matter, classification of matter, we talked about compounds and elements. So we know that compounds are composed of elements, of atoms. So this statement is still true. So we know that compounds are a mixture of atoms of different elements. Okay. And the last one, in a chemical change, in a chemical reaction, a chemical reaction involves only the separation, combination, or rearrangement of atoms. It does not result in their creation or destruction. So this is still true. In a chemical reaction, what we do, we just break some, as we call it now, bonds and forming new bonds. So we change the arrangement of elements and just place them in a different arrangement that I don't want to say we like, but it happens. Okay, so that's what happened in a chemical reaction. So if we look back at these four statements, so let's see which one of these four is still true. Okay, so the first one says elements are composed of tiny indestructible particles called atom. So this is mainly true, but well, not completely true as of now. So we know that now they can break the atoms and form new atoms, and that's what is called nuclear chemistry. Okay, so in the field of nuclear chemistry, atoms could be changed or destroyed, let's say. So it's mainly true, but not for all kind of reactions. So in the nuclear chemistry world, this statement is not true. So for the second one, it says all atoms of a given element are identical. You will learn about this in this course later, that we will have isomers. That in isomers we have different type of elements from the same type of atom, let's say, from the same element. We might have different isomers of iron, for example, and we will talk more about it in the later videos. Okay, so this statement also not true as of now, but you have to think about it. These are the initial ideas that started the name atom, and they started to introduce the concept of atom. So that was pretty good at that time. The third statement, it says compounds are composed of atoms of more than one element. This is still true. So as we know, compounds are a set of atoms that bonded together. And even the last one is still true. So in a chemical reaction, what we do, basically we just break some bonds, make some new bonds, we just rearrange the let's say how the atoms are bonded together and form new compounds. Okay, so this statement is also still true. So this is basically showing, in this figure, just showing what atomic theory is. So in the first statement we said that elements consist of indestructible particles, and the statement 2, it says these particles are identical together. So as you can see in element A, you have these blue ones and they are all just like each other, and in element B you see these green dots that are exactly just like each other. And in a compound, as it says in the third statement, that a compound is a mixture of how can I say that? So a mixture of elements formed together in a specific geometry, and you can see that it forms these compounds. A compound is from different elements. And also in the last one it says we do not destroy or make new elements. They just change their arrangement and form new arrangements for the product. So we can see that A formed reacted with B and formed a compound in the product, and you can see the number is also the same. So that basically shows the atomic theory in this figure.